Have you ever gotten one of those emails at work? You know the one. Planned maintenance this Saturday from 2 to 4 a.m. And you think, for a simple software update, really? Well, it turns out that updating something in a huge office environment is a whole different ballgame than just tapping Update on your phone. So today, let's pull back the curtain on the hidden and honestly fascinating world of technical change management.
Right. So think about updating your phone. It's a single tap. The process is designed for you and only you. But now, imagine you're in charge of updating a system for thousands of people across multiple time zones. That simple update just became a massive, high-stakes operation. It's really the difference between cooking dinner for yourself and catering a wedding for 500 people. The scale changes everything.
To make this all feel a bit more real, we're going to follow one single mission from start to finish. A company-wide printer driver upgrade. I know, it sounds almost painfully boring, right? How hard could that possibly be? Well, as you're about to see, even this tiny, simple task needs an incredible amount of planning, precision, and procedure to pull off without causing total chaos.
Okay, first things first. And this is probably the most important rule. No technician just walks up to a server and starts tinkering. No way. Every single action they take is laid out in a super strict playbook, a kind of blueprint for the change that gets approved long before anyone even thinks about touching a keyboard.
And at the heart of that playbook is a document called the change scope. It's a key part of a formal process called change control. And honestly, you can just think of it as the technician's official instruction manual. It's a formal piece of paper that says you are approved to do exactly this and only this between these specific hours. It draws a hard line around the entire job.
So back to our printer driver mission. The scope might say you have a 2-hour window to get this done. Now here's the kicker. Let's say the technician is a rock star and they finish in 30 minutes. They can't just use that extra hour and a half to, update Adobe Acrobat or patch another server. Nope. The window is for the printer drivers and the printer drivers alone. Sticking to that scope is what prevents one little change from accidentally breaking 10 other things.
But you're probably thinking, what happens when things don't go according to plan, right? What if our printer update needs a tiny tweak to some random file that nobody thought to list in the original scope? Well, any good process has a plan for that. If it's a small, absolutely necessary change, there are usually procedures that let the technician get approval to expand that scope on the fly, just enough to complete the main mission. It's all about having a documented plan, even for the unexpected.
You know, a really common type of scoped change you see all the time deals with allow lists and deny lists. An allow list is kind of like the VIP list at a nightclub. If your app's name isn't on the list, you ain't getting in. A deny list is the opposite. It's more like a bouncer with a photo of a known troublemaker. Pretty much anyone can come in except for the applications on that list. Actually, a great way to think about it is that your antivirus software is basically one giant pre-made deny list for all the bad stuff out there.
Okay, let's talk about a word that often goes hand in hand with change: downtime. This is that planned maintenance window you always get emailed about. You see, the goal of any good IT department is to make all this work completely invisible to you, the person just trying to get their job done. So how do they actually pull that off?
Well, the strategies are pretty straightforward, as you can see. Most changes happen during what they call non-production hours. Overnight, on the weekends, when fewer people are working. You'll always get clear emails about it, and there's usually a big central calendar so everyone in the company knows what's happening and when. But what about businesses that never sleep, like a hospital or a massive online store? For them, the solution is way more clever.
And this is how they do it. It's brilliant, really. They use redundant systems. Just imagine there's a primary system that everyone's using, and then there's an identical secondary system just sitting there waiting on standby. Technicians can redirect all the users over to that secondary system, perform the update on the now empty primary one, test it, and then switch everyone back without anyone even noticing. And the best part? If the update goes horribly wrong, they can instantly flip everyone back to the untouched secondary system. It's a built-in safety net that makes zero downtime updates possible.
But look, even with the most amazing plans and clever tricks, the real world is messy. Making changes isn't always a straight line from point A to point B. Sometimes it's more like untangling a giant ball of yarn.
And one of the biggest knots to untangle is dependencies. This is a technical domino effect. You want to update one application. Simple enough. But wait, it turns out that app won't work unless you first update a service that it relies on. Okay, but that service, in turn, needs an update to the whole underlying operating system.
All of a sudden, our simple little printer driver update now requires 3 other major updates on totally different systems before we can even begin.
And then there's this guy, the legacy system. Every big company has one. It's that ancient but absolutely critical piece of software that's been chugging along for decades. The people who built it are long gone. The company that sold it might not even exist anymore. It works, but nobody, and I mean nobody, has any idea how it works. It's the system that has a giant invisible sign on it that just says, "Don't touch."
So what do you do with a monster like that? You can't just leave it there forever. Well, the solution is to tame the beast, and you do that with documentation. A really skilled technician will go in and carefully study the application, documenting how to install it, mapping out all its weird quirks, and by doing that, they essentially bring this forgotten mythical system back into the normal support cycle. And, as a side effect, they instantly become the new and only in-house expert on it.
Okay, deep breath. The change is finally done. The printer drivers are installed. Mission accomplished. Time to go home, right? Not so fast. The job isn't truly over until you've managed the aftermath. The very first thing you have to do is verify the change. This can mean restarting a service or maybe asking a few users to log out and restart an app. Sometimes it even means rebooting the whole server. But here's the crucial part. This isn't just about making sure it worked. It's actually a planned test. By forcing a reboot now in a controlled way, you're proving that the system can recover from an unplanned shutdown later, like, say, a sudden power outage. It's pretty smart. Because systems are in a constant state of flux, any documentation, we're talking network diagrams, how-to guides, procedures, it all becomes outdated almost the second you write it. That's why any good change management process includes a rule. Updating the documentation is part of the change itself. Every single time you make a change to the system, you also have to update the map.
And this is where a magical thing called version control becomes absolutely essential. It's basically a system that keeps a detailed running history of every single change ever made. You could think of it like the undo button for an entire network, or better yet, a time machine. If a new update causes a huge problem, version control lets a technician see exactly what changed, and with the click of a button, revert everything back to the last known good version. It is the ultimate safety net.
And all of this leaves us with one final big question to think about. In a super complex technical world that is always evolving, which is actually more valuable? The system as it exists in this exact moment, or the detailed, documented history of every single change that brought it to this point? It makes you wonder if maybe, just maybe, the process is even more important than the product itself. Thanks for watching.